Okay, so hello everyone. In this video, we will cover transport layer and its functionalities. So, in this video, we will discuss about functionalities like end-to-end delivery, reliability, error control, congestion control and flow control, and multiplexing and demultiplexing. So, let's start with transport layer. So, the topic is transport layer. The transport layer is the fourth layer in the OSI model, which takes the data from the application layer and passes it to the network layer. Now, let's talk about the responsibilities of transport layer. What is the role of transport layer in the network? What are its functionalities? Like, first functionality is end-to-end delivery. The first and very important role of transport layer is end-to-end delivery. End-to-end delivery is also known as port to port delivery, which means they do end to end delivery by using port to port delivery. Okay, what is port to port delivery? Let's say there is some network A in which there are a lot of hosts. I have different hosts which are connected by some topology. Let's take one more network B. There is another topology in that network also, and devices are connected among themselves. Now, in this network A, host A1 wants to communicate with host B1 in another network. When A1 wants to communicate with B1, first of all, let's understand what happens at different layers. We already talked about data link layer. The responsibility of data link layer was then when message will be sent by A1, it determines which node it will go first. That was the responsibility of that data link layer. Okay, then from that node, which is the next node it will go on. This is the node to node. Hop to hop delivery was data link layer. The responsibility of network layer is different. In this A1 machine, which can be a server, a laptop, a mobile phone, or any other device, the responsibility of network layer is to carry message from this machine to that machine. But transport layer is working about that. It's about the network layer. Okay, and its responsibility is to end delivery or port to port delivery. Now, what is port to port? The A1 machine we have, it's possibly that multiple applications are running on A1 machine. Like in my laptop, I am working on web browser, multiple tabs are open here among different applications. Which application is transferring the data? Every application has its own port. So the port number is basically a 16-bit digit number. Among them, some are well-defined port numbers, some are registered port numbers like SMTP. If I am sending mail from my system, I am sending a simple mail, okay, through Gmail. Then Gmail uses SMTP protocol. The port number of that simple mail transfer protocol is 25. That means whenever data will be sent from my machine, the data is going through port number 25. When that data will reach B1, it reach on that machine. It's possible multiple applications are running on that machine also. From the multiple application, my message should reach which application? For that, we use transport layer, and it executes this by using port to port delivery. We have read data link layer responsibility also, that was node to node delivery. In transport layer, we are using port to port delivery or end to end delivery. The message was sent by port 25 of my machine. Let's say there's an application B1 and its port number is 120. The message should reach on that application only, not like all the applications are receiving that message. For that, we use transport layer. So the actual meaning of port to port delivery or end to end delivery is that from where the message is sent from our machine and on another machine it is received on the which application. This is called end to end because the end thing in my machine is process or program. Delivering message from my process to other process is responsibility of transport layer. That's why it's called end to end delivery, port to port delivery, or process to process delivery. Okay, now the second responsibility of transport layer is reliability. Another responsibility of transport layer is reliability. Transport layer uses two majorly used protocols, TCP or UDP, transmission control protocol and user datagram protocol. Other protocols like SCTP exist, but the most importantly used protocol are TCP and UDP. Now, if I'm using TCP, what is the advantage here? If I talk about network layer, we discussed in network layer about IP protocol. Whenever we send the message on IP protocol or network layer protocol, that message is unreliable. Okay, I am sending that message without any guarantee. But if I want to send that message with proper guarantee, if I want to achieve reliability there, then I will send that message through TCP. TCP provides reliability here. Okay, what does reliability include? If I have sent any 4 message or 4 packets, then receiver is also receiving 4 packets. This is the guarantee. Okay, secondly, it follows in order delivery, okay, of that message. In order means, let's say I sent message A, B, C, D. First I sent A, then B, then C, then D. Then receiver should receive first A, then B, then C, and then D. Okay, this is called in order delivery. Like in our laptops or system, when we press buttons of keyboard, let's say I press something like say LIVE. Okay, first I press L, then I, then V, then E. When this message will be printed on monitor, then it should be printed as LIVE. The order in which I pressed the buttons, printer on monitor showed it in the same order. That is called in order delivery. delivery. Okay, now if there is any mistake, let's say it receives some out of order packet like live instead of live, that's possible that it prints evil, so its meaning is changed completely. That's why I need in order delivery of packets here. And secondly, there shouldn't be loss of data. If I'm sending 4 packets and 1 or 2 packets are missing in between, firstly receiver should know that some packets are missing, and secondly each and every packet should be received there. This is the responsibility of transport layer. If you are using TCP, then TCP is a connection oriented protocol. Okay, connection oriented means it makes connection before sending message, like your telephone. If I want reliability there without any data loss, for that I can use TCP. This is the advantage of transport layer. If I don't need reliability, then normally I can use UDP. Okay, so if on your application layer, like we send web pages through HTTP, if I need reliability there, then I will use TCP for sure, because it works on connection orientation. Now the third responsibility is error control. Okay, the third responsibility of transport layer is error control. It does error control by checksum, and error control is also done by TCP. In TCP we basically use checksum method. Okay, checksum helps in detecting errors. We discussed that we try to detect error in data link layer also, but there we use CRC. Okay, and here we are using checksum, and we use the checksum method in transport layer. This error control is done end to end. When this message will be sent to B1 by using checksum at its own end, B1 will try to match that checksum sent by the user machine. B1 will calculate the checksum of that data again. If that checksum matches, that means there is no error. Okay, if that checksum doesn't match, then there is error. But in data link layer, every node tries to detect error, so that's why here we control error by using the checksum method, and in data link layer we control error by CRC method. Now the another responsibility is congestion control and flow control. Flow control means by what speed sender is sending message to the receiver and of what size. For this we use advertising window method here. Receiver already sends it window to the sender that this is the size of my window, so whatever the message you are sending, that message should be according to the window. Window is kind of capacity. Okay, receiver already told its capacity to the sender. It will inform about both. Okay, first the size of message and then how many messages of that size. When both the things will be known, then sender will send the message accordingly. Okay, from that my flow will be controlled. But if there wasn't a flow control, then there can be congestion in the network. If there's congestion on the network or on the server, then transport layer tries to remove or avoid that congestion also. There is a method like AIMD. This is the method which is used to do congestion control. Now in transport layer we use the terminology called segment. Okay, this is called segment. When data comes from application layer, that data doesn't have any defined length. Data comes in continuous stream. Continuous bits are coming. Okay, 01010101, and I can't send those bits further directly. I have to put it in proper segment where I have to set a header. Along with that there will be data. So what are the TCP and UDP doing here? Whatever message is coming from above, they are using or they are sending those messages to the network layer by providing them in the segments, because the message coming from above is continuous. Now the bits are coming continuously. They will pick up those bits, put them in the segments and send it down. That is called segmentation. Now one more responsibility of transport layer is multiplexing and demultiplexing. Whenever the data comes from the application layer, a lot of protocols and application are running on the application layer. Now multiple tabs are open on my laptop, multiple applications are running. It's possible that some application from those multiple applications are sending their data. Let's say 4-5 applications are there: A1, A2, A3, A4, A5. Okay, all these applications are sending data. Then transport layer doesn't make specific connection for all. In our laptop there's only one connection, so whenever multiple applications send data or messages, then transport layer works by multiplexing it. Okay, many to one, it sends that to the channel. The media or channel we are using, data from multiple application comes and data is sent to the channel, and at the receiver end messages are coming continuously. But it is possible some messages are for some other application, some are for some other application. Okay, now messages are in different application. At the end of receiver, it is working as demultiplexing, one to many function, because multiple messages are coming, a lot of messages are coming from one channel. But a message, for example, it's like Gmail. For example, it's Gmail, another message is for other application, other message is for some third application. Okay, so sending those message to the correct application, that is also the responsibility of transport layer, and we call this as multiplexing and demultiplexing. So this is all about the responsibilities of transport layer. We will discuss these functionality in detail in our upcoming videos. So that's it for this video. We will meet in next video. Until then, bye bye.